All right, so tangents and normals. So just a quick reminder of what an actual tangent is. So I'll sketch a function. Doesn't matter what it is. Let's just make it y equals x squared. And I'll draw a tangent in at a particular point. So if we drew a tangent in, the tangent just touches the curve at one point. And we find the gradient for this by finding the derivative at the point that we're looking at. So if we called that point A, what we're after is the derivative, so f dash of x at x equals A. And that's going to give us the gradient of the tangent. So because the tangent's a straight line, then you're also going to need the point that it goes through. So if we've got this point A, then we need to work out the y value at that point as well. So we have f of A. That'll give you the y value. And then what we'll use is y minus y1 equals m times x minus x1, which is the equation for a straight line, and all a tangent is a straight line. So let's have a go at the example that's in there. So we've got y equals x cubed plus a half x squared at the point x equals 1. So the first thing is we need the derivative to get the gradient. So the gradient of the tangent is given by dy dx. And if we do dy dx for this function, we will get 3x squared. Bring the 2 to the front for the half x squared, so 2 times a half is 1, and reduce the power by 1, so that'll be plus x. And what we want, though, is at x equals 1. So at x equals 1, dy dx is equal to 3 times 1 squared is 3, plus 1 equals 4. So now we've got the gradient of the tangent, we know that's 4. And the next thing that we need is the point that it goes through. So at x equals 1, you need to work out what y is. So y is equal to, and just substitute x equals 1 into your equation. So 1 cubed is 1, a half times 1 squared, so 1 squared is 1 times a half is a half. So it becomes 1 plus a half, which is, of course, 3 on 2. So your equation of tangent is given by y minus y1, so y minus 3 on 2, equals m times, so m is 4, that was the gradient, x minus, and what was the x value? It was 1. And now we'll just simplify that a little bit. So y minus 3 on 2 is equal to 4x minus 4. Move the 3 on 2 to the other side, so you'll have 4x minus 4, and then that'll become plus 3 on 2, or plus 1.5. So 1.5, if you add negative 4 plus 1.5 will give you negative 2.5, which is minus 5 on 2. Now, if they have a fraction in any of the terms, often what they'll do is not show you that fraction. So they'll multiply everything by whatever the denominator is. So if we multiply everything by the denominator, we'll get 2y equals 8x minus 5. And usually when they write it in that form, they'll put all the x's and y's on the same side. So 2y minus 8x is equal to negative 5. You could also multiply everything by negative 1, and then you would have a positive 8x, and you would have minus 2y equals 5. Any of these forms where I'm putting the asterisks is fine, but you certainly have to be able to get from one form to the other. And that gives us our tangent for that particular example.